So lucky to have Courtney Crosby here from Booz out in Hamilton, the Director of AI Special Missions. And if you can get a few minutes to talk with Courtney about the huge variety of activities that she's been involved with, as well as the time that you spent downrange, I think that would be of special interest also.
Yes.
And thank you so much for coming and playing today and sharing your visions.
All right. Just going to make an assumption here that we all trust each other. Yes. I know there's a couple guests, but I will offer you so that you can have a little bit of trust in me. I promise I will not call on you while you're eating. However, we are going to do this together. So as we talk about futures, and I was thinking about this session, so to speak, I did have a lot of conversations with folks in leadership here at the university. And the one thing that came up, no matter who I talked to or what the topic was this idea of interdisciplinary by default. And so what I thought would be good, I think that we've heard from a lot of people who are absolutely the experts from a technical standpoint when it comes to AI, was to actually come into this conversation with y'all and maybe contextualize a lot of it. I think that's what we're trying to do as we consider all of these unique problem sets and the unique skill sets that everybody in this room brings to the table, is really understanding how we operationalize this so that our students can take what they're learning and apply it when they leave the campus. So that's kind of the whole idea today. We're going to start with some problems and then work through a couple things together. This is my personal perspective on futures. How many of you have an idea of what you think futures is? Yes? Yeah.
The future is for AI. I'm talking specifically about my discipline, my technical area, construction engineering and project management and civil engineering generally. We are changing the way that we do construction projects by using cutting-edge technology, by using AI, and of course AI plays a significant role in all of these high-tech technology.
Absolutely. You can kind of see some examples here, right? But the whole point of futures is using time to your advantage instead of it becoming a disadvantage, right? The way that I like to think about this is that the problems that we were solving 5 years ago are table stakes today. A lot of the techniques that you heard from folks this morning are things that 5 years ago would have been impossible to solve. We didn't have the resources, we didn't have the compute, we didn't have the talent, that now are low-hanging fruit. So as you think about that, right, I want you to think about how we approach this with the idea of applied foresight. Okay? How do we understand impossible things today will be very easy at a certain point down the road? So I'm going to give you two options. Okay, I'm going to show you two slides. I want you to pick. You get to either pick this first slide if you identify with this, or you can bet on a slide that you have not seen yet. How many of you identify with this slide? Raise your hand. You solve problems, problem solvers. All right, a lot of problem solvers. The rest of you are betting? It's absolutely a trick question. Okay. See problems. Okay, that's what I want all of you to get toward today. Yes. I promise in all the places and with all of the people that I've done this, archetypes very much fall consistently between those who believe that they solve problems and those who take the risk to see problems. So that's what I want to think about today. We're going to work together. Again, we all, this is a nice, happy, safe space, right? Right. All right, so I'm going to pose a scenario to you. I want you to think about picking you up, and I'm dropping you somewhere on the globe. You don't know where you are. You've been blindfolded. You don't know how you got there. You need to figure out where you are. Think about it. Someone go about figuring out where you are. It can be technical or not.
Sun.
I promise I won't discriminate. The sun. Okay. So we're using references around us. The sun, maybe, who said that? Boom. Easy. There's your solution. You can open it. All right. So we're going to use references around us. We're going to use the resources that are around us that are occurring in the natural environment. The sun. Who has another idea? Yes.
Ask someone.
Ask someone. Whoa. Novel. Novel. All right. What about the stars? Right? If we can use the sun, we can use the stars. The sun, we might actually want to look at shadows from the sun. Yes. Okay. Somebody give me some algorithm, process, or system that you think could solve this problem for you. Yes? GPS. Winner, winner, chicken dinner. You can open that. All right, GPS. So, how many of you know what an OEM is? Yes. Of course the business guy knows what an OEM is. Business, right?
Oh, geez. Now I have a brain freeze. Oh, just forget about it.
Okay, that's okay. We can fill with each other. All right, an OEM is a vendor. This is typically thought about within the AI world, right? As somebody who has a product, usually a hardware product. So think a GPS provider. So if you could solve this with GPS, that would be so super cool. But what if you didn't have GPS, right? We were talking earlier about the research team who solved a problem that nobody else was solving with AI. Let's assume that we have this problem set, and everybody that's coming to the table to solve it is an OEM. They're GPS providers, right? They have GNSS modules. They want to come to the table and sell you some hardware. And you say, no. We're going to sell this with AI. Somebody name a company, person, startup, VC, doesn't matter, something in industry who you think in a non-GPS OEM capacity is working in this space. Maxar. Who knows who Maxar is? Satellite imagery. The amount of commercial to government-owned satellites in space today, anybody know the ratio? About 2 to 1. There's more commercial satellite imagery being produced across the globe today than there is government imagery. Why does that matter to us at this university?
Cost of accuracy.
Thank you. Huge change in the way that the government is now acquiring commercial data, right? It takes a really long time. Guess in time span here. How long does it take for you to request satellite imagery from a government agency? Do we think it's days, weeks, or months? Months. Yes. Okay. So, good point. All right, you're Maxar. You work at Maxar. We're solving this problem. All right. Type of talent that we need to solve the problem. Throw it out. Job families, positions, titles, labor categories, doesn't matter. Who do we need? Who do we need to hire? What researchers do we need?
Entirely team suitors.
Fabulous. Okay, we're getting some domain experts. Who else?
Some computer vision stuff.
Yeah, it's almost like maybe we're at an AI colloquium, right? All right, so we want some computer vision experts because we're using some imagery. All right, all of you are coming to the table with a solution who have bags. Pull your stuff out of your bags. As they're doing that, how many of you think that solving these problems is really easy? Raise your hand. All right, so what you're now seeing is the dynamic within the AI industry today. Somebody hold out something that you have so everybody can see. All right. What was the problem that we started with? Who remembers? What are we trying to do? Where are we? All right, we have to find where we are with one solution. And we need to build that solution. Let's assume that we're building it physically today in this room. And I need you to come to the table with your magnetiles. And I need you to come to the table with whatever those are. And your Lincoln logs or Jenga blocks. And your Legos. How are you guys going to build this?
With a non-profit private institution as a integrator to create an open systems architecture that's not owned by one organization.
All right, so today we talk about open source, right? We talk about stacks. It's almost like we coordinated this in advance. How do you do that though? How do you get your magnetiles to stick with these guys?
Face value, I don't know. You would probably need like a TPM or someone to help put all the pieces together.
Cool, cool. Where do you come in? What's your advantage here?
I got an API.
Not the notional advantage.
Okay. Each one of these blocks represents some place on the face of the earth, and I know where that is, computer vision-wise.
Okay,
Yours are pretty sturdy.
they are sturdy.
Yeah.
All right, point being, these are the problems that we're solving in AI. It really doesn't matter where we are. Lots of people can provide lots of pieces of the solution. We can talk to commercial vendors. We can hire the right people. We can use the right methodologies. The problem is not where you are. The problem is how you get the magnetiles and the connectors and the Jenga blocks and the Legos to all work. Okay? How does this show up in the real world? Anybody know what this is? Come on. It's a drone. Okay, cool. Massive, massive brownie points if somebody knows what UAS this is.
I would have brought different people here if I knew that.
All right, this is a scan eagle. Somebody guess where on the planet I took this picture?
Washington. Kandahar State.
Kandahar, very close. Mazar-e-Sharif, Afghanistan.
Blue.
Yes, ma'am. All right. Who here has heard of Project Maven before? All right. Project Maven was the first attempt by the Department of Defense to utilize artificial intelligence algorithms to solve a problem. One of the 3 people who know what Project Maven is. What problem were we solving?
ISR problem.
ISR problem. Phil, you're coming with all the answers today. ISR problem. All right, in Afghanistan, we have a lot of drones going at the time, right? So this is 2017. We've been in Afghanistan for a very long time. We have a lot of assets collecting a lot of overhead imagery, yes? How much of that imagery by percent are US analysts looking at? 10%. What else? Other guesses?
0.01%.
All right, so we're all super confident in the military-industrial complex, is what I'm hearing. 13%. 13%. From a resource perspective, that's pretty bad. Lot of imagery that is going completely overlooked. We are not putting it back into the intelligence cycle. What do we do with that? So somebody in the Pentagon said, we should solve that. It's a pretty easy problem to solve, right? We learned about computer vision this morning. We're talking about it a little bit as we walk through these scenarios. Somebody said, how can we exploit overhead imagery faster using AI? Quickest thing we were going to do at the time, let's use some computer vision algorithms to start doing what an analyst is doing. Looking at imagery and identifying, putting a box, and telling me what that box means. Very simply, we're talking vehicle, person, weapon. Okay? Super simple. All right. How many people think we could build algorithms that did that in 2017 for this type of problem set? We had algorithms off the shelf. Raise your hand.
You didn't have to compute and see to.
Okay. You're getting ahead of me, Phil, but all right. Let's see where you're going with that. All right. How many people think that we could develop algorithms fairly quickly to solve that problem? Raise your hand. You're shaking your head. Okay, be confident, be confident. All right, quick answer. We could actually do that. Okay? We could actually develop algorithms on data that we had available to us in the US military to solve this problem. What we did was we developed those algorithms here in the United States. We pushed them overseas. I was on the first 4-person team deploying those algorithms into Afghanistan. It was our Sharif. What went wrong? Guesses. Accuracy. What else?
Environment.
Environment. Almost like you served. What else? Bureaucracy. Okay. Security. Money. All right. Lots of constraints, right? That's what I'm hearing. Lots of constraints. Our job as educators, as futurists, as people who care to think long term, is not to mitigate the constraints, but to work within the constraints. Okay? We are not going outside the lines, right? I love the idea of coloring outside the box. In our world, in a lot of these real world problems, we are not coloring outside the box, we are coloring very, very brilliantly inside the box. Okay? All right, so we talked about environment. What do you think happened when we put these GPUs with algorithms into Afghanistan?
Could have been the altitude, it could have been the dust.
Okay,
Could
dust.
be,
What does dust do to compute hardware?
Not good.
All right. It was July. What else was going on in Afghanistan? Super hot. Super, super hot. All right, so what happens to a GPU, for any of my hardware folks in here, when it is super hot and there's a lot of dust? Okay. All right, so you start to see a little bit how an algorithm problem is not always an algorithm problem. What happens when a GPU gets really hot and it's very dirty? Doesn't shut down. Give me a different one. Okay. One of the things that it does first, as a self-preservation mechanism, is the fan starts to go very, very fast. Has anybody been inside a server room, and are they super quiet? All right, so what happens when you put an algorithm in a box and you send it to Afghanistan and you put it into an operations center? It's too hot and there's a lot of dust and the fan is going and it's really, really loud. Do you think that that is super easy to conduct operations if you are in the military? Probably gonna piss you off. All right. Anybody describe to me literally any type of hardware? Gaming systems, NVIDIA hardware, what color is it? Black. What happens when you send black stuff to Afghanistan? Really, really hot. But an engineer in Washington, D.C. did not think about the fact that in Afghanistan it would be really hot and black maybe wasn't the right paint color. Maybe we actually wanted to put silver. Was the problem the algorithm? All right, so when we had this black painted system that overheated, that was really loud, that pissed off the battle captain because nobody could hear him. What do you think happened next? They don't use it. Unfortunately, though, I think somebody this afternoon is talking about human performance. Who's talking about human performance? Okay. So, what I would have liked to have on that team is somebody from human performance. Would have really liked somebody who understood that we should probably institute some MIL standards for hardware that hadn't previously been deployed before. Anybody in here in art, humanities? Sweet. I mean, color theory would have been supreme when we were designing this thing. It actually blew up, and then nobody wanted to use it. All right. Point being, the problem isn't what you think it is. I want you to start thinking around the problem, okay? Right, time. We were talking about generative this morning, right? So as we start to think around the problem, we want to consider time, right? We are futurists at the end of the day, and time matters. Imagine that this is a generative AI timeline, insanely simplified, okay? So 2014, Ian Goodfellow publishes his academic paper on GANs, which is largely attributed to kind of kickstarting what we now consider to be the current state of generative AI, right? A couple things happen, OpenAI comes onto the scene. We talked about ChatGPT 2.5.
2 and 3.5.
2 and 3.5. That's why you need the experts. So if you see this timeline and you see that ChatGPT as we know it today has, in some form, been around since 2014, what is the difference? What changed between 2014 and 2022?
Number of people using it.
Say it again?
Number of people using it.
Number of people using it, okay. What else?
Actually, since I know 14, whose model cams were just to generate images. Now with ChatGPT, because we use the transformer, so we have to generate text. We could also do sound, videos, so all kinds of that.
So we've moved domains. What else? Access. The thing that happened, that is the reason people in this room who are not Ali know about ChatGPT, is because you gained instant access to it. Carrie didn't have to go in and play with it. You could. That is what changed. All right, so this is the original publication on arXiv. What's the thing that matters in this overview? This is Ian Goodfellow's initial submission, 2014. We're maximizing the probability of making mistakes. We're finding the edges. We're seeking out the problems. How many people think Ian knew that he was proposing maybe a bigger philosophy here? And he didn't. All right. So if you were to extrapolate that forward, right, 2014 to the way that we use ChatGPT today, right, what does that look like from a time horizon perspective? We're talking about a student that is coming on campus very, very soon, who is going to develop something that in 2032 is going to have the type of impact that ChatGPT has today because of access. The people you are educating are making decisions today that maximizes the decisions we get to make in 2032.